Imagine you have a Terraform configuration that creates one S3 bucket. You run Terraform apply, the bucket appears. Exactly what you intended. Now run it again. What should happen? If you reason about it for a moment, the answer feels obvious. The bucket already exists. The configuration says there should be one bucket. There is one bucket. Nothing needs to change. Terraform should look at the world, compare it to the configuration, find no difference, and do nothing. And in this specific case, with this specific tool, that's exactly what happens. This property, that running an operation multiple times produces the same result as running it once, has a name. It's called idempotency. And it is one of the most important properties a provisioning operation can have, because it is the property that makes retrying safe. The reason retrying needs to be safe is that provisioning operations fail. And when a provisioning operation fails partway through, the universal recovery action is to run it again. If the operation is idempotent, running it again is safe. It will complete what wasn't done and skip what was. If the operation is not idempotent, running it again can be significantly worse than the original failure. So far, so reassuring. Terraform handles the bucket case correctly. What could go wrong? Here's a different scenario. You have a script, a bash script, or a Python script, or a sequence of AWS CLI commands that provisions an environment. The script creates a security group, launches 2 EC2 instances, and registers them with a load balancer. You run it. Partway through, the network connection drops. The security group was created. One of the 2 instances was created. The second instance creation timed out before you knew whether it succeeded. The load balancer registration didn't happen. You run the script again. The security group creation fails because the security group already exists, and the create command returns an error when it finds a duplicate name. Your script, which wasn't written to handle this case, exits on the error. Nothing else runs. You still have one instance, no load balancer registration, and now a script that can't complete because it fails on the very first step. This is what non-idempotent provisioning looks like. The script was written for the first run. It wasn't written for the second run, and in the real world, where networks time out and pipelines get interrupted and engineers close their laptops at the wrong moment, the second run is not a rare edge case. It is a regular operational requirement. The question of whether your provisioning is idempotent is not a question about whether it works correctly the first time. It's a question about whether it works correctly the 15th time, after 14 retries from 14 different failure points in 14 different partial states, leaving behind 14 different combinations of partially created resources. Now let's push the thought experiment further, because the script failure is a simple case. The more interesting case is when idempotency appears to hold but doesn't, when a provisioning operation returns success on every run and still produces the wrong result. Here's the scenario. You use an infrastructure tool that creates resources by name. On the first run, it creates a database instance named prod-db. You change your configuration. You want the database to use a different instance class and run it again. The tool checks whether prod-db01 exists. It does. The tool concludes the resource is already provisioned and skips it. Your configuration changed. The tool saw the name, declared victory, and moved on. The database is still the wrong instance class. The tool reported success. You have a system in the wrong state and no signal that anything went wrong. This is idempotency by name only. The tool checked whether the resource existed, not whether the resource matched the desired configuration. These are different checks. The first confirms presence. The second confirms correctness. A provisioning operation that is idempotent with respect to presence, but not idempotent with respect to configuration, is a provisioning operation that can silently diverge from its declared intent every time the configuration changes. Terraform solves this with its plan and apply model. It compares the full desired configuration against actual state, not just whether the resource name exists. This is why Terraform apply on a changed configuration correctly updates the existing resource rather than skipping it. The check is deeper than existence. But Terraform's model has its own idempotency gap, and it lives in the state file. Terraform tracks what it knows about the world in a state file. The state file is the source of truth that the plan and apply comparison runs against. When Terraform creates a resource, it records the resource in state. When Terraform deletes a resource, it removes it from state. The The state file and the real world are supposed to stay in sync. They don't always. If a resource is deleted outside of Terraform, manually, by another process, by a cleanup script that didn't update state, it still exists in the state file. Terraform's plan says 0 changes. State shows the resource exists, and the desired configuration says it should exist, so no action is required. The resource is gone. Terraform believes it's there. Your application tries to use it and fails. If a resource is created outside of Terraform, a manually created security group, a database instance provisioned through the console in a moment of urgency, it doesn't exist in state. If Terraform's configuration also declares a resource with the same name, Terraform will try to create it, fail because it already exists, and report an error, not because the configuration is wrong, because state has drifted from reality. The state file makes Terraform's idempotency conditional. It holds as long as all changes to the infrastructure flow through Terraform. The moment a change happens outside Terraform's awareness, the condition is broken, and the next apply may fail, silently diverge, or produce a duplicate. This is not a criticism of Terraform. It is an accurate description of the challenge that any stateful provisioning tool faces. Idempotency, at the infrastructure level, requires a single authoritative record of what exists. The moment there are two sources of truth, the tool's state and the cloud's actual state, idempotency becomes a property that holds most of the time under normal conditions for operations that don't involve out-of-band changes. Most of the time, under normal conditions, is not a guarantee. So what does genuinely idempotent provisioning look like? It requires three things that are simple to describe and are non-trivial to implement consistently. The first is checking actual state, not recorded state. Before deciding whether to create, update, or skip a resource, the provisioning operation queries the cloud directly, the current actual state of the resource in the cloud's own systems. The second is comparing full configuration, not just presence. Presence is a prerequisite for correctness. It is not the same as correctness. The third is making all changes convergent. If the resource exists but has the wrong configuration, the operation updates it. This convergence property, that every run moves the world closer to the intended state, never further from it, is what makes an operation safe to retry unconditionally, not just safe to run once. Idempotency is not a checkbox. It's not something a tool either has or doesn't. It's a spectrum of how much of the provisioning operation behaves convergently under how many different conditions. Every deviation from full convergence is a condition under which retrying is no longer safe. The engineers who manage infrastructure at scale don't just use idempotent tools. They enforce the discipline that keeps idempotency intact. All changes through the tool, no exceptions. Run it once, get the result you intended. Run it 15 times, get the same result. That's the property. It sounds simple. Maintaining it requires treating every out-of-band change as a first-class threat to it.